Now let's have a brief look at how references will be used, passed into functions, returned from functions, and how they will be used in your custom classes. And along with that, we'll also review a certain rule that's important when you use the constant keyword on your variables and other items when they are in your custom classes. But first things first. I typed up some code over here to demonstrate, so let's have a look. Here's my main function. Before the main function, I declared two different other functions. They both don't return anything, they're void. This one is called doSomethingPtr, for short for pointer, and it takes a integer pointer as a parameter passed into this function. And this one is called doSomethingRef, and it declares that it will take a reference, an integer reference, as a parameter into this function. So here you see already how you're supposed to declare that your function will be taking a reference as a parameter. Pretty much identical to how pointers are declared as parameters, except that instead of the asterisk, of course, you use the ampersand. Everything else is pretty much the same. Like, for example, you don't have to have any name for this parameter over here. You can just declare what type it's going to be. But as usual, for clarity's sake, it's always a good idea. And then, for example, if you'd want to pass in a couple of different stuff into this function, you can pass in as many things as you'd like, each one separated by a comma, as we learned in a different video. Right now, we're just going to pass in one single integer reference. Now let's see what's going on in the main function. As you can see, I'm declaring this variable with 73, and then I'm calling the function doSomethingPointer. And as such, I need to pass in something that'll be validly accepted for this integer pointer. And of course, I'm passing in the address of my variable x. As we learned in a different video, that you can pass into a function that's expecting a pointer either a pointer object itself or a plain old address of a variable, and that will be accepted into the called function as a pointer, or rather as a valid value to be stored into the pointer in the called function. So whatever memory address x is stored at, that number will be put into the pointer. That memory address will be stored into the pointer. But right over here, you could see I'm calling doSomethingRef, and here I'm just passing in the plain old variable x. At first glance, this can seem a bit confusing. It looks as if I'm just passing in a plain old integer variable, as if I would have declared that it's not going to be a reference, just that I'm passing in a plain old integer into this function by value. Because unlike when I pass in a pointer, we don't need to pass in the address of the variable. When we just pass in the variable itself, the program will automatically take care of the headache of getting its memory address and assign that to the reference in the called function. Much like when we learned about creating an integer reference, where we saw that we don't have to give the address of the variable to the reference, but rather just the variable name itself, the same holds true when passing a reference into a function, or rather when passing something into a function that's awaiting a reference. All you gotta do is pass in the variable itself that you want to be referred to in the called function, and the program will automatically assign the address of that variable to the reference in the called function. Now, of course, just like with pointers, you could decide to pass in either an actual pointer, which was declared before, or just a plain old address of a variable, and both of these are acceptable to the called function. The same thing is true when passing into a function that expects a reference. You could either pass into the function an actual reference object that you created, or you could just pass in a plain old variable all by itself, which will be both acceptable in the called function. And now here's the implementation of both of those functions. Here's the definition. As we see here in the pointer function, the pointer needs to be dereferenced in order to take action upon the variable that is being pointed to. However, in the reference function, we could just use the plain old name of the reference as if we were handling the variable itself. successfully overcoming the obstacles of scope, because whatever we are doing to this reference over here will take actual permanent effect on the original integer x that we created in the main function, as explained extensively in different videos. Just a little important footnote about terminology here. In both of these functions, we are doing something called passing by reference. Both the pointer function is passing by reference, and the reference function is passing by reference. The difference is that the pointer function is passing by reference using pointers. The reference function is passing by reference using references. The concept of passing by reference is that trick which enables us to affect different variables across different scopes, like in this function down here, where we could take permanent effect on the original variable which was created in main, even though main is one scope and these functions are two other different scopes. But still, because we are doing some specific magic called passing by reference, we are able to overcome the limitations of scope. So whether you're using pointers or references, both of these formulas are referred to as the magic of passing by reference. So you could do passing by reference using pointers, and you can do passing by reference using references. Which now brings us to the obvious question: if all we are trying to do is passing by reference so that we can overcome the limitations of scope, why should I use pointers over references? Or why should I use references over pointers? Which one should I choose to use? Well, we will explore the different advantages and disadvantages of each one as we go on. The first one I'll mention right now is the amazing simplicity and cleanliness of using references instead of using pointers. Whereas pointers need to have some special little operator sticking around every step of the way. Of course, when declaring this parameter, we need the asterisk, but then when we try to pass something in, again, we need to pass in the address of some variable. Same thing like when we want to make a pointer point to some variable, we need to use the address operator. And then once again, each time you want to use this pointer to access whatever it's pointing to, you'll need to use the dereferencing operator each time again. In some cases, this would require some parentheses to make sure that dereferencing is done properly, like in this case over here, where we don't want the plus plus operator to happen before dereferencing the pointer. And if that's all not enough, what about when you have a pointer that's pointing to one of your own custom classes, like this example myOgre over here? As we will learn, in order to access this instance of the myOgre class's functions, you'll either need to use parentheses and the dereferencing operator, or the alternative arrow operator, which again we will learn about in the future. So basically, pointers are a little bit of a mess when it comes to using them, with all these little operators and symbols that we have to keep typing all the time. Whereas when we're using references, it's as easy and as clean as if we're using the name of the original variable itself. So as soon as you've declared your reference, and you've assigned what it will be referring to, you could use it as cleanly and as easily as if you're using the name of the variable or the instance of your class itself. And we seem to achieve the same goal of getting over the restrictions of scope through passing by reference, the same kind of magic that we are doing with pointers. So that's definitely one up for references, but as we'll see, there are many different times which you will not be able at all to use references, and you will have to use pointers.